Okay, so today let's work on normalization. Normalization is one of the very important area where you have to learn, in a very proper way, right? So be on track, always be on track, and try to understand the normalization, right? So those who are in the mic, please mute it. And the normalization we are going to learn today, the normalization normally applies. Normally we are applying this normalization in a very huge table with more errors. So the normalization, using this normalization, these errors will be reduced, and we will get the very simple and very normal tables. So those if you are taking this table, then the error level would be very low. That is the ultimate goal of making this normalization. So we will be go one by one, right? So there are some important what is that important wordings before we move the normalization. The first one is dependency, right? The dependency is the first one. There are some important points we need to note. One is this multi-value attributes. Already we have learned about this multi-value, or else we can say repeating groups. So make sure that you take a pen and paper, because we will be doing more exercises today. Okay, uh, we will be uh, the first one is multi-value attributes. So another word is repeating groups. So you can see, you can read further: non-key attributes or group of non-key attributes, the value of which are not uniquely identified by directly or indirectly, not functionally dependent on the value of the primary key, right? So now you can understand this, right? Now you can understand. So after some time you will understand, right? So now I'm moving the next one: partial dependency. um, that is a second word. Okay, another one: transitive dependency, that is a third word. Okay, these three words, three these three words are very important, right? Partial depends. Okay, apart from this, I'm going to start with, right? I'm going to start with um, I'll go to I'll share some my whiteboard, then we will be going with them, right? Okay, not this. Okay, now we are in the process of learning normalization here, right? And come to Normalization. Okay, now we are going to learn the normalization. Before start, we have a couple of words we need to go for. One is multi value. Second one, functional dependency. Third one, partial dependency. Fourth one, transitive dependency. Right. If you can understand all four things, so it would be very easy to understand the normalization. Okay, so one by one we will go. The first one, going to touch multi-value attribute. So the multi-value in the sense, so take this table, then you will understand very easily. Multi-value, right? So I'm writing ID, name, subject, credit, right? 101, 101, 102, 103. Name A, A, B, C. Subject, say we will say computer, chemistry, chemistry, science. So we can say credit 3, 2, 2, 2. Right. If you see this table, okay, if you see this table, normally we take this ID as a primary key, PK, primary key. Primary key, we know there should be no duplication. Duplication should not be there. But you can see, you can find some duplications. 101A, 101. Why this duplication is coming is, now you can see the person A, he is taking computer as well as he is taking chemistry. Because of this subject, our primary key is getting duplicated. Normally, this place we are calling this is multi-value. So this, because of this subject, this multi-value, our record is being duplicated. 101A, 101A. Since 101 is a primary key, it should not be duplicated. It should not be duplicated. So we have to be so careful on it. The normally the primary key must not be duplicated. Okay, right. So why it is being duplicated is, now you know the case. What is the case? That because of this subject, it is being duplicated. Because of this subjects, it is being duplicated. So the subject is multi-value. Now you can see the subject, same person is taking this computer as well as this chemistry. So the subject is two subjects, the person who is taking. So if you take this table, the 101A, 101A, this is duplicated. That is damn clear, right? That is the theory behind the multi-value. Suppose if you have another person, 104, his name is D, he is taking English. then credit to 104, name D, taking the subjects maths, credit to. Now you see, this also the case, 104D, 104D. Because of he is taking science and English, the duplication is happening. So that is we are telling the multi-value. This subject attribute is multi-value attributes. Okay. The normalization, if you take the normalization process, right? So we can find zero normal form, first normal form, second normal form, third normal form. We will learn up to this today, right? So while you are going this way, while you are going this way, the complexity and error will be reduced. When you reduce this complexity and errors, then your tables will be easy to modify. Modify in the sense you will be, you can mitigate or else reduce the anomalies. Anomalies mean problem. We already learned this one: insertion, deletion, update, this kind of problems, errors we can reduce. Okay, right. So if you see here, right, the next one is functional dependency. When you understand the functional dependency, this all can be understood easily. Right? Now I'm going to teach about the functional dependency. Okay. Now try to understand the functional dependency, which is easy, and you have to be very careful while you are looking into. Okay. So the functional dependency, right? Now you can see there are two important word. One is dependent, dependent, word one. Second one, determinant, determinant. This is word two, right? So these two words are important if you want to understand this functional dependency. These two words are very important. Okay. Now we will learn about this dependent and determinant. Okay. Now, for example, you take your ID and name. Okay. Now, try to understand this case. Um take this ID and name, right? I'm going to write some example here. ID 101, 102, 103. Say name A, B, A, right? So Amal, Amal, Bimal. Okay. Now you can understand if you take the ID, maybe this is primary key, this is alternative key or else none key, right? So 101, his name is Amal. 103 also Amal. This is different Amal. This is another boy Amal, right? Then 102 Bimal. Okay. Now you can see if you take Amal, if you take Amal, then what is what is his ID? Whether you will write 101 or 103, which one you write? So you cannot tell this one. So if you call Amal, then one note person also will come, 103 person also will come. So uh, you cannot determine this one, Amal, right? So you cannot uniquely identify a person by calling Amal, right? That is why we learned about that name cannot be the candidate key. Name cannot be the candidate key because the name can be duplicated. The names can be duplicated. Okay, I had one call. So we can come here the name. We can't have this what is that primary key because of this case. So you can see if you call Amal, we don't know who is going to come and meet. But if you say okay, 101 is 101 come here, then this Amal will come. And 103, then this Amal will come. So at that time we don't have any problem. Now simply we can write like this, right? The ID I uniquely identify name. ID uniquely identify name, right? This one is our case. The name is identified by the primary key ID. The name is identified by ID, right? So you can draw or write like this. ID determines name. So we have two words, dependent. So the name is depending on ID, the determinant. ID is determinant, right? ID is uniquely identifying. So we are just talking the name is depending on ID. This dependence we are telling functionally depending. That is why we are telling FD, functionally depending, right? I'll just give another example. Okay, I'll remove this one and I'll give you some other example. Okay, right. Now I'm going to write, I have A, B, C, D. I have 4 attributes and I'm going to write A, B, C, D. No, I'll just make it like this. First of all, uh, B, C, D. Now you can see here, uh, as already we learned about, one is dependent, second one is determinant. Right. Now you can see A will be the determinant. Dependent, B is one dependent, C is another dependent, D is another dependent. So we use this arrow to show this relationship. We use this arrow to show the relationship. So you can, if I write like this, you can simply, you have to understand this is determinant, this is dependent. Simply you have to understand this determinant and dependent, right? We are talking about functionally, functionally, right? Functionally depending, functionally depending on A. B is functionally depending on A. C is functionally depending on A. D is functionally depending on A. So this is the case that functional dependency, right? You need to know about dependent and determinant, right? Normally the determinant most of the time primary key, right? Most of the time, okay. So the dependent, so no alternative keys or else other key, even candidate key also, uh, even candidate key also can come under dependent variable, right? Now another example I am going to say B. So simply I can go with like uh, A, B, C, D, E, F, G, right? So you have 1, 2, 3, 4, 5, 6, 7 attributes. Now I am going to write A, B, A, C, A, D, A, E, A, F. Then F, G, F, G. Okay, it means, so you can see this B, C, D, E, F, B, C, D, E, F, all are depending on A, depending on A directly. Now, if you see the G, G is not depending on A, it is depending on F. It is depending on F. You can see here, G is depending on F, depending on F. So, this depending mean, you know, whatever that we have learned, this depending mean dependency, you know, functionally depending. So this G is depending F, but G is not depending on A. But other way around, it is important point that I have to tell, indirectly depending on A, right? You have to understand this. So you can see this one, A, B, C. Now you can see, I'll draw like, what is this? B depending on A. What is this? C depending on B. Now A determines B, B depending on A, as well as C depending on B. So the C is, the C not directly depending on A, not directly. Directly mean like this. See, this is directly. B directly depending on A. C is not directly depending on A. C is depending on B. B is depending on A. So we are telling indirectly. Indirectly, this C depending on A. Indirectly, not directly. So, but if you see, if you take this one, B, the B is directly depends. But if you take the C, it is indirectly depends on A. So these two, direct dependency and indirect dependency, you have to understand, right? You have to understand, right? I'm going to write another example. AB, AC, AD, CL, LX, right? So um, okay, now just unmute right, unmute Tilara Sesadi. Yes, unmute.
Sir.
Okay, good. So now you understood what is dependency?
Uh, B is functionally dependent on A.
Okay.
C is
C,
functionally dependent on A.
fine.
D is functionally dependent on A.
Okay.
L is indirect
Functionally depends on
dependence on C.
C, fine. X,
X is functionally dependent on L.
L. Okay. Now I want to know whether L is functionally, you know, depends on A or not.
Not.
No, 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 no. That is the case. Okay. Right. Now, not in the functionally, this is direct, but this case indirect. But functionally depends. Okay. Got the point?
No, sir, can't understand.
No. Okay. So you just do not, mute, right? You just be online with me. Now you can see A, B. This is you understood. A, C, understood, right? I am using the word directly, right? Then indirectly, two words, but
Mhm.
functionally directly depending, functionally or else indirect, functionally indirectly depend, right? Both are functionally depending, but one is directly depending, another one is indirectly depending. That is the difference. So C is functionally directly depending. So if I take the L to A, L here, A here, L is depending on C, C is depending on A. It is coming like that, right? It is coming on like that. A functionally directly depending, the C is directly depending on A, L is directly depending on C, right? But A, L, this is functionally depending, that's fine. But direct, no, indirect. Indirect, yes. Got the point now?
Yes, sir.
Good. Now tell me, X, if you take the X, is that functionally depends on A or not?
Functionally depend.
Yes. Okay. How it comes functionally depends on A, X. What is the, the pathway it came? How we can say functionally depends on the A, the X? First of all, A, C, then C,
L.
L, then L, X. So A, X. Because you can see the relation. So we can say A, L is, sorry, X is functionally depending on A. But this is not the direct. This is indirect. Okay, fine. Okay, mute. I hope that others also can understand what I taught. Okay, right. One student is asking, A is the determinant. Is it only A? Right. So that is depend on the case. Say for example, in this case, determinant A, dependent B. This case, dependent, determinant dependent. So it is we are telling this determinant and dependent case by case. So in this case, dependent is X, determinant is L. Determinant dependent. Got the point? The student who asked this question. Yeah, got the point? So it is case by case. Always that is case by case. So you can understand on that. Right. Now hereafter, don't forget this functional dependency. Functional dependency can be a direct and indirect, but all are functional dependency. Right. So if you can understand the functional dependency only, we can go further. Okay, fine. So now next one, partial dependency. Partial dependency. Hope now you understood the functional dependency. Now I will come to the partial dependency. Right. Now let's take the relation student. Right. A, B, C, D. So here, this is the primary key. Mm, rather, I add another couple of letter, then you can understand easily. Okay. Now, I'm going to write A, B, C. So here, this is determinant. So C is dependent. This is composite primary key. You can see underline A and B. So another one, A, B, D. Right. See, E is depends on only B, only B, not A. You can see here, only B. Okay, try to understand. Next one, F depends on E. Right. Now, going to teach you the partial dependency. Partial dependency. See, the C, the C. If you take the C, it depends on A comma B. This is composite primary key. We can say, see, the C is depending on both A and B. So we can say fully functionally dependent. Then now hereafter we don't need this functionally dependent, because if you just use the word that is functionally dependent, this is fully dependent in the A and B, the C. If you take the D, it is depending on A and B. A and B. Then this is also fully dependent. Take the E. E is depending on only the B, not the A. Here we are telling partially depending. So this is we are telling partial dependency. So you can see here E, F. E, F. This is F is functionally depending on E. So because the E is not the primary key, so we can simply say F is functionally depending on E. Okay, but here A and B, C is totally depending in the A and B. Then if you take the D, it is also totally depending. E, it is only depending on B. So here you can see this point. Then after that EF. So here we can say partially depending. Partial dependency mean this one. So here you can see this is fully depending. This is fully depending. This is partially depending. Partially depending on the primary key. But in this case, in this example, primary key is compose. Compose primary key. Though we have composed primary key, the E is only depending the on the B, not the A. So this case we are telling partial dependency, right? This is partial dependency. I'll just have another example. Another example I'll show you. Then you will understand this one. Okay. Now I'm writing A, B. Sorry. C, A, B, E, M is depending on B, X is depending on A, L. Right. Now, in this case, we can write all these letters A, B, then you have C, there you have E, then you have M, X, L. So we can see AB as a composite primary key, right? Now you can see C and E totally depending. So I can draw like this, C and E. So from the A, B, C and E totally depending. So M depends on B. X depends on A. Then again L depends on M. So if you take this one, okay, right. Now we can say, okay, in this case, in this case, I just call Ravin Chamod. Ravin Chamod, yeah, you are there. Ravin Chamod, you are there. Unmute your mic. You are there. If you are not here, then I am going to remove. I can't hear you. Hello?
Hello sir, මේ එයාගේ මයික් එක වැඩ කරන්නේ නැහැ.
කාගේද?
රවින් චමෝත්.
දැන් කවුද කතා කරන්නේ?
හරිද ශ්‍රීමන්.
එහෙමද?
මැසේජ් එකක් දාලා තියෙනවා බ්‍රෝ.
එහෙමද? ආහා. ඔව්නේ. Ravin Chamod, prepare your mic, eh? Right. ICT 30, ICT 30, ICT 30. ICT 30. Hishan Vimukti. Hishan
Yes,
Vimukti.
yes sir.
Okay, Hishan. Right. Very good boy. Right. Hishan, now you understood the concept?
Halfly.
Okay, very good. Then in this case, you can see my diagram, right? Not the diagram, that my, drawing here, right? So which is partial dependency? Show
Uh,
me.
B B partial dependent in
Reverse,
M.
reverse, reverse of that. M is partially depending on B.
Oh, M is partial
Good.
depending on
Another one. You can
X is
find another. X is
X is partial depending on
on
A.
A. Okay. Let me know the fully dependent, the full dependency.
Uh, E
Yeah.
to AB.
E fully depends on primary key. Another one.
C.
C. Very good. Right. So you have to, okay, mute your mic. So now I hope that you guys, boys and girls, that can understand this partial dependency concept. Now this, you can see this, what is that? This and E and C fully depending, the M and X, that is partially depending on primary keys, right? The L is functionally depending on M, that is different story. So if you just go with this partial dependency story, definitely there should be composed or else composite primary key, then only the partial dependency story will come, otherwise it won't come. Simply we can say functionally depend. So if you want to if you find any word like partial dependency, definitely 101% definitely there will be one composite primary key, otherwise you don't have this story. It means that partial dependency story you will not have unless you have the composite primary key. Okay, so far we have learned about the FD and partial dependency. Now the third one we are going to learn, TD, transitive dependency. Transitive dependency is very easy. You can see a non key field or attribute is functionally depends on another non-key attribute. This is called transitive dependency. It means one non-key non-key attribute, alternative attribute or non-key attribute depending on another non-key, right? Not the primary key, depends on not the primary key, it depends on another non-key attribute, right? You can understand this with this example. Now you can see A, B, C, D. Now A is a primary key, right? Right. Now you can see A determines B, A determines C, C determines D. Now the B, you can see this B is a non key. This is primary key. C non key. This is primary key. C is a non key. D is a non key. Now you can see a non key attribute D depending on another non key attribute C. This is we are calling transitive dependency. Try to understand, right? You can see the B a non key, this is non key, but depending on the pk, so it is like this. So in other word I can go like this, right? So the non key depending on the primary key, right? This is normal situation. If you see like this, a non key depending on another non key, this is we call transitive dependency. Without any doubt you can say this is transitive dependency because one non key is depending on another non key, right? Now let's go with one example, then you can understand. Mm, right. Now you can see uh, the C, this fellow C depends on A and B. That is C would be one non key depending on the primary key. Now we will take the D. D is a non key depending on A comma B. Okay. Now next one, E. E a non key depending on D. D is a non key. Then this is transitive dependency. Now uh, again E, that is we have gone, right? Then F. F is depend on C. C again it is a non-key. F also a non-key. So we can say this is transitive dependency. Again F is depends on E also. You can see F is depends on E. So this is also a non-key. This is also a non-key. So again this is also transitive dependency, right? Now you can understand what is exactly the transitive dependency. Transitive dependency is simply this one. a non key depends on another non key. This is partial, we can say transitive dependency. Simply, we can say this is the transitive dependency case. Okay, right. So now you know about FD. Second, you know about partial dependency. Third one, transitive dependency. Now, if you know all these things, then we will go to normalization. Right. Now I'm going to share the our slide. Then you will understand now. Okay. Hope you can see my PDF document here. Okay. Now you can see the dependency, right? Partial dependency. Partial dependency, you can see here customer ID and the name, customer ID and the name, order ID, three things there. Now you can find uh, customer ID also underline, order ID also underline. It means the primary key would be a composed one. Composed one. If you have this composed primary key, CPK, you can expect the partial case, partial dependency, right? If you have CPK, if you just a single primary key, it is you don't have any option to talk about the partial dependency. But if you have composed primary key, then only you will be finding this partial dependency case. Now you can see here, if you take the customer ID, name, order ID, the name, you can see their name depending on customer ID, but not in the order ID. The name only on depending on the customer ID, but not in the order ID. So that is why we are calling this is partial dependency. Okay, right. The next one, as I taught you now, transitive dependency. You can see um, the department ID. The department ID is a non key because primary key is here, right? It is a non key. Again, department name is a non key. So now you can see this arrow. One non key is depending on another non key. So this is clearly we can say transitive dependency. Clearly we can say that is transitive dependency. One partial dependency, one student is asking for partial dependency, primary key is always composite. Yes, if you if you have the story one like a partial dependency, definitely there will be a primary key will be composite. Then only the partial dependency katava will come. Otherwise, it will not come, right? So definitely there will be a partial, sorry, composite primary key if you find any partial dependency. Now you can see here, uh, this is non key, this is non key, then this one depends on this, so this is we can say transitive dependency. Transitive dependency. So this side you don't have any problem. Employee ID is a PK, then this one depending, this one depending, this one depending, no problem at all. Okay, So this is already now we have learned now. So before I come to this slide, that is why I taught you. Right. Now, now we will be learning the normal form, right? So before the normalizing, we are calling unnormalized, or else you have another word called um, unnormalized or zero normal form, 0 NF. From 0 NF to 1 NF, 1 NF to 2 NF, 2 NF to 3 NF. Okay, so that is we are telling starting table, that is zero normal form. So if you see there, if you just go with this 0 NF or else unnormalized form, there are multi-valued attributes or repeating groups will be there, right? You can see there, right? Can you remember that in the table 101 A, 101 A, 101, 102B, 102, 103C. So this A is taking computer and maths. So this one taking arts and commerce subject. So see 101, 101, A. Primary key should not duplicate it, but because of this subject, the subject, so it is getting 2 times. So this is, we are telling, repeating group, repeating group. So we must not have the repeating group in the first normal form. That is why we are telling no multi-valued attributes in the repeating groups. So in the no first 0 NF, you can find the repeating groups, or we can say multi-value attributes. Both talks the same story. Multi-value attributes or else repeating groups, both same story. Right, now we will go one by one. Right, before that we will go this this one, the story. Now if you are in the 1 NF, this case you will not find any multi-value attribute, because from here 0 to 0 NF to 1 NF, so the activity is removing multi-value attribute. That is the process happening. So if you want to convert from 0 normal form to first normal form, you will remove the multi-value attribute, right? Then 1 NF to 2 NF. If you want to convert the process is removing partial dependency. From 2 NF to 3 NF, if you want to convert the form, the process happening removing transitive dependency. That is why I taught partial dependency and transitive dependency. So up to this we will be learning. So from 0 NF to 1 NF, while you are converting 0 normal form to first normal form, you will remove the multi-value attributes or else repeating groups. From 1 NF to 2 NF, you will be removing the partial dependency. Then 2 NF to 3 NF, you will removing the transitive dependency. So all these things can be seen continuously, right? Now you can see here. So now whether I want to know whether this is which normal form I am sitting. Okay, so now you have been given this case. Now you can see ISBN underline. So this would be the primary key. This is a none key. This is a none key. This is a none key. Okay, so now you can see according to this, according to this, um, ISBN title. Title is depending on the next one. ISBN depending publisher. So the you can see the title here depending on ISBN. Publisher depending on ISBN, right? Now you can see the address here. Address depends on publisher. Depends on publisher. Okay, so you have three dependency here. Functionally depend title is functionally depending on ISBN. Publisher is functionally depending on ISBN, and the address is functionally depending on the publisher, functionally depending on the publisher. So you have three dependencies here. Now we will go one by one how to work on this. How to work on this. Now you know everything. Okay, right. So from 0NF to 1NF, carefully look into. So here our activity is removing, repeating group, or else removing multi-value attributes. Okay, removing multi-value attributes. Right. Now I told you some time back, so in a whiteboard, we were learning about directly or indirectly depending on primary key. This word, this sentence I used directly or indirectly. Uh, Someone's mic is on. Please mute your mic. I don't know who's that one. Someone's. So in this case, you can see I use the word directly or else indirectly depending on the primary key. Okay, right. Now I'm going to share the whiteboard again. So still that the mic is on. Who is that? Please mute your mic. Someone is some Chamika Chamika Dinusha. Your mic is switched on, and okay. Then now so I will go with okay. Right. Now I'll show you the conversion. Try to understand. Right. One is 0 0NF to 1NF. Right. Here I want to remove multi-value attributes. Right. Now A, B, C, D, and E. Right. Now just look carefully. I am just drawing the what is that functionally dependency. Now you can see if you just see the all the attributes, somehow it functionally depends on somehow it functionally depends on the primary key. Now you can see all the attribute B, comma, C, comma, D, E and E all are functionally directly or indirectly depends on A. This case, if you find like this, all the other key, all the attributes directly or indirectly depends on primary key, then make sure there will be no multi-value attributes. There will be no multi-value attributes, right? This is one important point. So you have to understand, right? If you find any case that attributes, the given attribute directly or indirectly depends on primary key, then directly you can say no multi-value attribute. If you say no multi-value attribute, mean that is first normal form. Our from 0 NF we are removing the multi-value attribute, it will become first normal form. So if you find no multi-value attributes, then we can say that is first normal form, right? See now, um, A, B, C, D, right? B is functionally depending on A, C is functionally depending on A, D is functionally depending on A, right? Now I can say the B, comma, C, comma, D somehow directly or indirectly depends on A. So there is no multi-value attribute because all the attributes B, C, D, all the attributes are directly or indirectly depending on primary key. So this relation in at least one NF. One NF. Why one NF? We don't have any multi-value attributes here. Why we don't have multi-value attributes here? All the attributes B, C, D somehow depends on A. Somehow depends on A. That is why we can say this relation is in at least. Why we are using the at least? It may be 2NF, it may be 3NF, but that is why we are using at least 1NF, right? Okay, another example, A, B, C, D, E, F, right? Now you can see, right? Now if you see this F, E, D, C, B, all are directly depends on A. So there is no multi-value attribute. So this relation is in at least first normal form. This is how we will be writing. So if I ask like the question like this, then directly if I will give this one and I will ask, okay, determine this relation in which normal form. So you have to understand, right, how to work on it. Now you can see the B, C, D, E, F all are depending on A, directly or indirectly depending on A. So no problem. So there is no multi-value attribute. If everything depends on directly or indirectly depends on A, you will not find any multi-value attributes. That is the theory. So this relation is in at least one NF. Okay. So um, there's another simple complicated example now I am going to give you, right? Then you will understand. Okay, now little bit complicated I am giving. Okay, A, B, C, D, D, E. Okay, now you can see A determine B, A determine C, A determine D, D determine E. Now we can see this B, C, D and this all directly depends on A. The E is indirectly, because you can see D is depending on A. From that D, E is depending. So the E is indirectly depends. So I can say the B, comma, C, comma, D and E somehow directly or indirectly depends on A. So there will be no multi-value attribute. If it is no multi-value attributes, we can say the relation is at least in one first normal form, right? Already that we have seen that we all are directly depending on A, but here B, C, D are directly depending. At the same time, E is indirectly depending on A. So either directly or indirectly, the attribute depending on the primary key, we can simply say there will be no multi-value attribute. If you don't have any multi-value attribute, then simply in the next line you can write the given relation is at least in at least first normal form, right? So that is the case from say zero normal form to first normal form. We are removing multi-value attribute. That is the first process, first activity, right? The second activity is 1NF to 2NF. Before that, we will go with our note, right? Now you can see in this case, title, publisher, title and publisher and address. Now you can see the public address is only depending on this publisher, but title and publisher directly depending on ISBN. The meanwhile, address is indirectly depending on the ISBN. So simply you can say all the attributes are directly or indirectly determined by the primary key. Therefore, the relation is in at least one NF. So I hope you can understand this. Then I can give you only 1 minute. The students, those who can't understand, please tell me. Just if you ask any doubt, I will be clearing now. I can give you only 1 minute. So I need to go further. Anyone? If you have any doubt, you can ask me. Okay. So one student is asking, tell me one zero enough example. Okay. Right. So again, I'll move to my whiteboard. Right. Now I'm going to show 0NF example. That is good. I forgot actually. I need to tell that one. Okay. Now, um, A, B. Okay. Now it's a primary key. Right. Now you can see, guys. Uh, A, B, C, A. So B and C depends on A. E is depends on D. Right. Now, what is our case in a 1NF? 1NF, if it is, if you are telling, okay, this particular relation is 1NF, it should be the no multi-value attribute. If we no multi-value in attribute, in the sense there will be no repeating group. It means whatever the activity you are doing, all the attributes are directly or indirectly depends on primary key. Now, the primary key here is A. A is a primary key. B and C, it is directly depends. Right. If you take the D, D is directly or indirectly not depends on A. See, B and C. A is not determining the D. So you don't have this case. You don't have that one. So in this case, the D is not directly or indirectly depends on A. In this case, D is not directly or indirectly depends on A. So this case, if you find like this, it means uh, this particular any attribute, if it is not depending directly or indirectly in the of the on the primary key, then simply you can say the multi-value attribute is there. This is multi-value attributes. This is multi-value. So in this case, um, multi-value attributes is there. If you have multi-value attributes, simply you can say this is zero normal form. Because if you are telling 1NF, no multi-value attribute. But in this case, multi-value attribute is there. D is multi-value attribute. So this D is not depending on A, right? So the D is not depending on A. So this is simply zero normal form. So if you decide this is zero normal form, it is not necessary to check the 1NF or 2NF or 3NF, because we confirm that this is 0NF. So we don't need to go further. So this is the 0NF concept. Okay. So I'll just give another example. So A, B, C, D, F, X. Now you can see, uh, now you can see A comma B determines C, A comma B determines D, F determine X. Right. Now the X, So this X, the F, this one directly or indirectly not depend on the primary key. So you can find there will be multi-value attribute. If you find multi-value attribute there, then that is zero normal form. Okay, so that is the case. Just give me 1 minute. Hope that you understood this case now. Right, if you have any doubt, just ask me. Meanwhile, I'll go to this note, right? So now you can see the case. This is important point. All attributes are directly or indirectly determined by the primary key. Therefore, the relation is at least 1NF. Why 1NF? So the publisher, the address is indirectly depending on primary key. Title, this one. This is direct, this is direct, this is indirect. So all the attributes are somehow depends on ISBN. So we can say no multi-value attribute. So uh, the relation is at least 1NF. Done. So this is how you have to write. So I will give this one, then I will ask whether this particular relation is 1NF or 2NF or 3NF or 0 or which normal form. So you have to find whether the particular all these conditions, and you have to give the results. You have to write like this. You have to justify it, right? Why it is 0NF or why 1NF, why 2NF, why 3NF, you have to justify it, right? Right, now you can remember, from 1NF to 2NF if you want to go there. So already you have here 0NF. You are removing the multi-value attributes. Then you have 1NF. Now this is already in the 1NF. See, all the attributes are direct or indirect depend on ISB. So simply you can say this is 1NF, at least 1NF. Now you can see here no partial dependency. Do you have partial dependency? No, because you have only one primary key, no two things underlined. So you don't have any partial dependency, right? Now from 1NF to 2NF, the activity is removing partial dependency. If you remove the partial dependency, it will be 2NF. Now already this is already removed. So because you don't have any composite primary key here, so simply you can say the relation is at least in 1NF. That is already we know. Now there is no composite primary key. So therefore there can't be partial dependency. So no composite. So no partial dependency. So if you find the composite only, we have to think about the partial dependency. Here you don't have any composite one, only one attribute is underlined. So simply you can say, therefore this relation is at least 2NF, at least in second normal form. Right. Now, now you can see, while you are seeing this one directly, directly, indirectly, while seeing this one you can say, so at least 1NF. We'll see whether this is 2NF. 2NF mean there should be no partial dependency. Partial dependency katawe naha. Why? Because I have only one attribute and it is primary key, so no partial dependency. If you don't have any partial dependency, you can say, so this relation at least in second normal form, because no partial dependency. Now the second normal form to third normal form, third normal form, we are doing the important activity is removing transitive dependency. Transitive dependency means one non key depending on another non key. Now you can see this is a non key, this is another non key. So this non key depending on this non key. So you can find this is transitive dependency. If you find transitive dependency, then it is not third normal form. It is not third normal form, because in the third normal form the transitive dependency will not be there. You see, second normal form, third normal form, from second normal form to third normal form, while we are moving, we have to remove the TP, transitive TD, transitive dependency. So if you find a transitive dependency, definitely you can say this is not third normal form, but it is 2NF. Right. The next slide, it will be more clear. You can now you can see publisher is a non-key attribute and determine the address. You know, the address is a non-key, publisher is a non-key. So so it is one non-key is determining other non-key. Therefore there is a transitive dependency. This is transitive dependency, this one transitive dependency. So if you find transitive dependency, now you can say it is not in third normal form. In the third normal form, you will not find any transitive dependency, but you can find here transitive dependencies. So simply you can say this is not third normal form, but it is second normal form. It is very simple in finding the cases. Now you can see we know that the relation is at least in 2NF and it is not in 3NF. Therefore, we conclude that the particular relation is in second normal form. Right. This is the whole story. In your answer, you will write this justification. So simply you can say no multi-value attributes. Therefore, we can say first normal form. So everything I taught you now. Okay, now you can see this is directly depending, indirectly depending. So first normal form, you can I don't have any composite attribute, so no partial dependency, so it is at least in second normal form. Now you can see this is one non key, this is non key is depending another non key, so this is not 3NF because transitive dependency is there. The relation the relation, the conclusion is the relation is in second normal form. This is how we are writing the justification, and this is how you have to write in the final exam paper also. If I ask question, definitely I will ask question. You have to write like this. Okay. um, Now you can see here product ID description. So in this example, see here, this is composite. You can see underline. This is composite primary key. Right. Now we have to think about whether this is 1NF or not. Right. So the attribute somehow directly or indirectly depends on the primary key. This is primary key. This is a primary key. This is partially depending. It is not the story, but it depends on the primary key. If the attributes, all the attributes depend on the primary key, then we can say that is 1NF. It means there will be no multi-value attributes. Partial, we don't talk about the partial from the first case. From 0 to 1, all the attributes directly or indirectly depends on the primary key. Partial primary key is for the second stage, but this is our primary key. Yeah, one student is asking, is there any way to remove the transitive dependency? Definitely, I will be teaching you little bit later. Right, there is a case how we remove the transitive dependency. I will be teaching you. Right. So now if you see here, this is first normal form because the attribute is depending on the primary. Right. Now we need to think about whether this is 2NF or not. If it is 2NF, there will be no partial dependency. But you can see here our primary key is order ID, order number, and product ID. The description is only depending on the product ID. So this is partial dependency. If you find partial dependency, it is not second normal form. So we can say simply it is first normal form. That's it. Simply you can write that. All attributes are directly or indirectly determined by the primary key. Therefore, the relation is at least first normal. Now, now you can see here, right? One student is asking whether how we can find the description depends on the both primary key or one primary key. Yes. So that is already I just talked about here, right? So simply you can see, um, if it is composite mean A and B, this will be the primary key. If it is a composite, then this will be the primary key. Then other things, if it is depending on like this, that is perfectly fine. Perfectly fine. So, but in some case, if it is coming like that, only this, if this one we will give you, don't worry, you cannot by thinking or by assumption you can't take this one. In the exam paper clearly I will give you which are like this small diagram I will give you. According to the diagram you have to take. So simply now you can AB is a composite primary key, so F is only depending on the B, then simply you can say this is a partial dependency. CDE, that is fully depending on the primary key, but F is partially depending on the primary key. AB is a primary key, but F is only depending on the B. So that is a partial dependency. Hope I answered your question. So this in the exam paper I will give you everything. Fine. So now you can see the relation is at least in 1NF, it is a composite key. See, those are two underlined one. So definitely you can find a story like partial. So therefore there can be a partial dependency. Product ID, which is a part of primary key. Product ID is a part of the primary key. Primary key is this. Product ID is a part of the primary key. Determines description. This description is determined. So the arrow is here. So actually it is like this. Product ID determines description. So the arrow is like that. This arrow is this one. Okay, the same arrow is this. So the product ID determines this one. So this is dependent, this is determinant. Okay, so the description is depending only on the product ID. So this is partial dependency. If you find the partial dependency, then simply you can say this is not second normal form. In second normal form, you will not find any partial dependency. So simply you can say this is not second normal form. This is first normal form only. So you can come to a conclusion easily. We know that the relation is at least in 1NF and it is not in second normal form. Therefore, we conclude that the relation is 1NF, right? So second normal form we can't say because this is partial dependency is here. So I can't say this is second normal form. This is first normal form, right? So uh, in your solutions, you are writing like this. No multi-value attributes, therefore it is 1NF. There is a partial dependency. Product ID determines the description here, therefore it is not in second normal form. Conclusion, the relation is 1NF. So I'll be updating the slide, then you can go through this. It is pretty easy, right? We will go to the next example. Right here I have some small problem. This is the problem. Okay, right, this is the problem. So the part ID, it is determine description, part ID determine the price. That is this one and two. This is uh, it is wrong, right? Only comp ID determining the number. Comp ID determining number. This one wrong, wrongly. So while I am just passing this, please, because this is PDF already, please remove this part. Okay, just try to remember this is the 15th slide. Remove this part. Right, now you can see here, mm, that means there is no repetition of data in the third normal form to be found. Yeah. That's true. So not in the third, not only the third normal form, but also repeating group will be removed from the zero. In the first normal form, you will not find repeating group. If you can't find, if it is not in first normal form, second and third, there will be no repeating group, because already from 0 to 1, we removed the repeating groups. So you will not find any repeating groups in 1NF, 2NF, and 3NF. There will be no repeating group. Only repeating groups will be there in the 0NF. First NF, second NF, third NF, you will not find that. Right. In this case, if you come here, uh, okay, fine, good. Right. Definitely, you have to ask questions. Then only you can understand. Right. Then this is a different slot, you can see. Now I am going to write here, right, part ID description, part ID price. These two directly depending on the primary key. Part ID is the primary key, but you can see the comp ID. comp ID is not depending on the part ID. So part ID is the primary key. In the primary key, the part ID, oh, you can see comp ID. We don't have any option like this here in this case. You don't have any option there. So the comp ID is not depends on directly or indirectly. It is not depending on the primary key. Then simply at first slot you can say this is zero normal form. It is zero normal form. So if particular attributes either directly or indirectly depends on primary key, then we can say that is 1NF. No multi-value attributes. But here the comp ID is not depending on the primary key, part ID. So simply we can say there are multi-value attribute, it is 0NF. That is very direct. You can read here. You can read there. Comp ID and number are not determined by the primary key. Therefore, the relation is not 1NF. No sense is looking for the partial or transitive. So you don't need to look the partial or transitive because this is 0NF already. Multi-value attributes there. So we don't need to think about whether this is 1NF or 2NF or 3NF. It means partial dependency or transitive dependency. We don't need to think because already that is 0NF. Okay. Right. Then we will go with the next one, the same story. Okay. There are multi-value attributes, therefore not in 1NF. Conclusion, the relation is not normalized or 0NF. The conclusion, we can say the relation is not normalized, or we can write 0NF. Right. Now we are going to do the breaking part. How we are going to do this one? Okay, students, look carefully. Okay, easy. So if you take this table, now simply you can see the name is depending on student ID. Student ID is a primary key, but course ID, unit, these two are not depending on primary key. So this is 0NF. So this is depending on primary key, but course ID and units are not depending on the primary key. So this is 0NF. So we need to convert 0NF to 1NF. We need to convert it. We have to make it. Right? How we are doing that one. Right? So here, if you want to do, here you have two options from 0 to 1. If you want to convert 0 to 1, you have two options. 1, 2. One is not breaking the table. Second one, break the table. Not breaking the table. First how we will do is we will make student ID, name, course ID, all these things as a primary key. All these things as a primary key, composite primary key. Then you will not find any repeating groups. Repeating groups mean 101 Lennon MSI 250. So you can't find 101 Lennon 250 again. This is 415. So this and this now different because we merged everything as a primary key. 101 Lennon MSI 250, 101 Lennon MSI 415, 125 Johnson MSI. Now you can see there are no multi-value attribute because we merged. So the primary key is like this, student ID, name, course ID, all are primary key, comma, units. Then it will be depending on like this. Then you can see, simply you can see no multi-value attributes because unit is depending on this one. What is that? Course ID. So already you have this one, course ID. units depending on course id. So unit is depending on the course id. Simply you can say this is no multi-value attributes, so this is 1NF, but not 2NF, right? So only we are talking about 0 to 1. Okay, so that is the first method. That is the first method. It means not breaking the table. Simply what you will do is, which is uh, the point. So now you can this is the point, because 101 linen, the course id is not depending on the primary key. So definitely the problem start here, course id, because unit is depending on course id. So the course id not depending on the primary key, so problem start here. So we can make it primary key, then one two three tuples, right? Unique tuples, unique. See, 101 linen msi 250, it is not duplicating. 101 linen msi 415. So two different cases, right? This is not the same. Okay, so now you can simply say student name course, all are primary key, unit is attribute. So the unit is depends on part of the primary key, course unit. So simply we can say this is 1NF. No multi-value, no multi-value attributes, right? That is first style, to just make it 0 to 1, 0 to 1 NF. Now I am going to do second part, breaking. Breaking means we are breaking this part. It means it is non-primary, sorry, it is multi-value attribute. Because of this only we are repeating. So we break the table into two, so this is multi-value, this is, it depends on the unit is depending on this course id. So these two guys will be removed. Then student id comma name, then course id unit, then two table. Then if while you are breaking, you must have some kind of relation, otherwise you can't do queries. So simply I'm going to give cid to this side. So I have cid. So now you can see um, in the next table, now you can see I'm just composing. While I am composing, I just take the matters. Now I'm going to do some kind of breaking. So you can see the breaking point here, right? Student id name course id units, I am breaking here. While I am breaking, see, student id and name, simply I give the next one, student course student id, or else you can give other way around, right? I am giving this way around, student id. So breaking into two, while I am breaking to student id name, student id course units. Now you can see, now you can see the name, student id determines the name. So no multi-value attribute, it is 1NF. Here I have only one primary key, so no composite 2NF, right? So this is primary key, this is primary key, this is none key. So I don't have any transitive. Transitive mean nk determines nk. So simply I can say this is 3NF also. Simply I can say, right? Now you can see this is student id and course, both are primary key, right? So this unit is depending on this one. So no multi-value attribute, but partially depending on. Okay, so this is 1NF. 2NF, no, because partial dependency is there, because course unit is only depending on the course, not the student ID. So there is a partial dependency, so no 2NF. But this is also now 1NF, this is also now 1NF. So this is later on we'll see. This is also 1NF, that is also 1NF. So while you are breaking the case, you have to be remove the entire repeating group from the relation. You are removing this part. You are removing this part. While you are breaking, you are removing this part, course ID and unit and other part, because this is repeating group. MSI, this because of the course ID only, the records is being repeated. So create another relation which would contain all the attributes of the repeating group plus the primary key from the first relation. So I am giving the primary key student ID to other side. So you can see here student ID name breaking. I am giving the primary key student ID to other side. So 101 101 MSI. So this is the whole someone's the mic is on. Student ID course. This is okay. So you can uh, can't we get course ID to student table? Course ID to student table. You are just you want to put the no 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 no. From the you can see here. You can see here. Remove the entire repeating group from the relation. This is a repeating group, right? So I am going to remove this one right now. Course ID I removed. This is depending on this guy, so I need to remove unit also. Okay, now student is asking whether can't he send the course ID to other side, right? No, because the primary key from the first relation, right? First relation, primary key of the first relation should be added here. Primary key of the first relation must be added here. That other way around, if you work then I hope that should work, right? I didn't work that side. I work front side only. Whether I need to check and let you know whether that will be working all the situations. Okay, right. So I'm clearing this. So the first relation from the primary key from the mother table we need to take, right? Now you can see, right? Now this is the case we have. Now you can see this is uh, all. This is also 1NF. This is also 1NF, right? The next one, bringing the relation to second normal form. How we are going to bring this, right? Now you can see you have composite primary key here, right? Student ID, course ID. Okay, what's the time? Oh, come on, 2 o'clock. Okay, I will be. I'm going to stop now because we will be learning the same here. From here, we will be learning again. Don't worry. Um, Bringing from one, right? So from here to in the next class, I will be teaching you. So the next class, not the coming Thursday, before that I will be conducting the class and finish the series, and after that we will have some continuous practices, small examples and all. Okay, so I'm going to stop today now.